You think you understand emptiness because you interact with it every day. You clear a table, you empty a room, you open a box and find nothing inside. And your mind quietly records the same lesson again and again. When things are removed, nothing remains. This feels so obvious that it hardly seems like a belief at all. It feels like common sense. But common sense is often just repetition mistaken for truth. Because when you say something is empty, what you really mean is that it is empty of the things you expected to find. An empty cup is not nothing. It is air, motion, heat, pressure. An empty room is full of light, sound, invisible particles crossing every second, even deep underground, where silence feels complete. Radiation passes through you without permission. So already the idea of emptiness bends a little. Empty never truly means empty. It means empty enough for human purposes, but your imagination goes further. You picture a final emptiness, a place where absolutely nothing exists. No atoms, no light, no motion, a perfect blank. And this picture feels clean, stable, logical. Yet notice something strange. You can only imagine that nothingness as a place. You imagine a dark box, a black void, a vast silent arena. But the moment you picture it, you have already added something back in. You have added space. Space becomes the unnoticed assumption, the invisible stage where nothing supposedly sits. You remove objects but keep the container, as if the container does not count. This is the first crack in the intuition. Why should space survive the act of removing everything? Why does your mind insist that emptiness must still be somewhere? The problem is subtle because language hides it. Words like there, inside, and where smuggle space into the conversation before you even realize it. So when you say nothing exists, you almost never mean absolute nothing. You mean no objects existing in a place that already exists. Physics begins by questioning assumptions exactly like this. Because if space remains after everything else is gone, then space is not nothing. It is already something so fundamental that your mind refuses to imagine its absence. And once you notice that, the question shifts. You are no longer asking why objects exist in space. You are asking why the stage itself seems unavoidable. Why can't you think without it? Why does reality appear to require this silent framework, even before particles or stars arrive? The discomfort starts here. The idea of nothing begins to collapse not because of complicated equations, but because the very act of imagining nothing secretly rebuilds reality. You try to erase everything. And space remains silent, uninvited, persistent. As if emptiness is not the opposite of existence at all, but its first hint. Suppose you ignore the philosophical discomfort and proceed like a physicist. You imagine a region of space and remove everything from it. No dust, no light, no particles drifting through. A perfect vacuum, the closest thing physics can offer to nothing. This sounds straightforward, a calm, silent emptiness. But the moment physics examines this vacuum closely, it refuses to behave. You might expect stillness, absolute stillness. If nothing exists, nothing should happen. Instead, the vacuum flickers. Not metaphorically, physically. Energy appears and disappears. Tiny disturbances arise and vanish before they can be observed directly. The vacuum behaves less like a void and more like a restless surface that never quite settles down. This is wrong according to your intuition. Nothing should stay quiet. The source of this restlessness lies in a principle that sounds simple but cuts deeply. At the smallest scales, nature does not allow complete certainty. Position and motion cannot both be perfectly fixed. Energy and time refuse perfect definition. If you demand a vacuum with absolutely zero activity, you demand perfect certainty. And physics refuses to give it to you. So even the emptiest space carries fluctuations, temporary ripples that momentarily resemble particles, and then dissolve again. These are not little objects popping in and out like toys, appearing from nowhere. That picture is misleading. Instead, think of the vacuum as a field that cannot sit perfectly still, the way a stretched membrane cannot avoid tiny vibrations. Stillness itself becomes impossible, and this has consequences you can measure, too. Metal plates placed very close together feel a tiny force pushing them together, not because something obvious sits between them, but because the vacuum around them behaves differently than the vacuum inside the gap. The emptiness itself exerts pressure. Space is doing something, not hosting something. Doing something. This is where intuition breaks again. You were taught to think of activity as belonging to matter, things colliding, moving, changing. But here activity belongs to absence itself. The vacuum is not a blank page waiting for ink. It already contains rules, structure, potential. And once you accept that, a deeper question emerges. If empty space has energy, if it fluctuates, if it resists perfect silence, then what exactly did you mean by nothing in the first place? It begins to feel like a word that physics cannot locate. You can remove particles, you can remove light, you can cool systems near absolute zero, but you cannot remove the background murmuring of reality. The vacuum refuses your command to be empty, and this refusal suggests something unsettling. Maybe emptiness is not what remains after things are gone. Maybe emptiness is an active condition that exists whether you want it to or not. The stage is no longer passive. It trembles, and once the stage moves, you start to suspect that the actors, the particles themselves, may not be what you thought they were either. You were taught to imagine the world as objects. Tiny hard pieces moving through empty space. Electrons like little beads, photons like tiny bullets of light. Space as the arena they travel through. This picture feels natural because it mirrors everyday life. Balls roll across floors. Planets move through the sky. Things exist first, and space simply allows them to move. But Richard Feynman helped push physics toward a quieter, more radical idea. What if the objects are not fundamental at all? What if what you call a particle is only a disturbance, a temporary pattern, in something that already fills space? To see the shift, imagine the surface of the ocean. A wave moves across it. You might point to the wave and treat it as a thing. You can track it, measure it, watch it carry energy. But the wave is not separate from the ocean. Remove the ocean, and the wave has no identity. It is not an object traveling across water. It is water moving in a certain way. Feynman's worldview suggests something similar about reality. Electrons are not tiny marbles drifting through emptiness. They are excitations of an electron field, a field that exists everywhere, even in regions you would call empty. The same for light, for quarks, for every known particle. Space is not an empty container holding things. Space is filled with fields, and particles are moments when those fields vibrate in particular patterns. This is a quiet but devastating inversion. You think matter is primary and space is secondary. This is wrong. In modern physics, the fields spread throughout space come first. The particle is the event, not the substance. Notice what this does to your intuition about emptiness. If the fields are everywhere, then even a region with no particles is still full of potential activity. The vacuum is not blank. It is fields resting in their lowest possible state. And resting does not mean dead silence, as you already saw. It means the minimal motion allowed by the rules of nature. Suddenly, space and matter begin to blur together. When a particle appears, nothing new enters from outside. The field shifts. The vacuum rearranges itself locally. Existence looks less like objects occupying space and more like space organizing itself into temporary patterns. You can feel the discomfort this creates. If particles are merely disturbances, then solidity becomes an illusion of persistence. The things you call objects are stable patterns in an underlying. See, you are not living in a universe made of things. You are living in a universe made of behavior. And the behavior belongs to space itself. Feynman didn't present this as mystical or dramatic. He treated it as the most practical way to calculate reality. But hidden inside that practicality is a philosophical shock. The vacuum is not a gap between objects. It is the continuous fabric from which objects emerge. And if that is true, then asking why space exists starts to sound like asking why waves exist without acknowledging water. The question begins to turn on itself. Because perhaps space is not what things exist within. Perhaps space is what things are. Now imagine trying to go further. You decide the quantum vacuum is still too much, too active, too full of hidden structure. So you ask for something more extreme, a universe with absolutely nothing at all. No fields, no particles, no energy. True nothing. At first this sounds like a cleaner idea, simpler than a restless vacuum, a final erasure. But the moment you try to describe it, the idea begins to collapse. Start with a simple question. Where is this nothing? The word where immediately fails. Location requires space. Distance requires space. Direction requires space. Without space, there is no meaning to left or right, near or far. So you remove space as well. Now ask when this nothing exists. Again the question breaks. Time requires events that can change from one moment to another. With nothing present, there are no events, no sequence, No before or after. So time disappears to. At this point you might feel satisfied. You have removed everything, but something strange happens. The concept itself stops being meaningful, because to distinguish nothing from something, you need a comparison, a boundary, a framework that allows difference. Without any structure at all, you cannot even define what nothing means. It becomes less like a state and more like the absence of states entirely, not a condition that exists, but the absence of existence as a category. Physics struggles with this because physics describes relationships, measurements, interactions, quantities compared to other quantities. In absolute nothingness, there are no relations. No ruler to measure distance. No clock to measure duration. No observer to ask questions. Even logic becomes slippery. Saying nothing exists secretly assumes a universe where statements can be true or false, and that already introduces structure. You begin to notice a deeper problem. Perhaps absolute nothingness is not difficult to achieve. Perhaps it is impossible to even formulate coherently. The mind keeps smuggling pieces of reality back in space, time, language, comparison, because without them the idea dissolves. This is not a technical limitation of experiments. It is a conceptual limitation of thinking itself. And this realization reshapes the question you started with. You asked why space exists as if non-existence were an equally valid alternative. But what if non-existence is not a valid option at all? What if the very possibility of asking questions requires some kind of structure, a framework in which distinctions can exist? Space may not be one feature among many. It may be part of the minimal scaffolding required for anything to be definable at all. The desire for absolute emptiness starts to feel like asking for a sound without vibration, or a shadow without light. You can say the words, but they point to nothing coherent. And so the intuition shifts again. Maybe emptiness is not the baseline from which existence emerges. Maybe existence, in some structured form, is unavoidable. And if space cannot be erased even conceptually, then it stops looking like a coincidence. It starts looking like an ingredient reality cannot do without. If space cannot be reduced to nothing, then the next step is unavoidable. You have to treat it as real. Not metaphorically real, not a useful backdrop. Real in the same sense that matter is real, something that influences what happens. And once physics does this, strange consequences appear. The first is energy. Empty space contains energy even when no particles are present. This is not an abstract bookkeeping trick. The universe behaves as if the vacuum itself stores a kind of tension, a baseline level that cannot be removed. You don't see it in everyday life because it is quiet, uniform. But on cosmic scales, uniform things matter. In the late 20th century, astronomers discovered that the expansion of the universe is accelerating. Galaxies are not merely moving apart from an initial push. The expansion is speeding up, as if space itself is pushing outward. The simplest explanation is unsettlingly direct. Empty space has energy that drives expansion. Space does not just sit there while the universe evolves. Space participates. This undermines another deep intuition that causes come from objects interacting with other objects. Here, the cause seems woven into the background itself, and the more you look, the more space behaves like a structured medium rather than a void. Gravity, according to modern physics, is not a force pulling objects through empty distance. Massive objects change the geometry of space and time, and other objects follow the paths that geometry allows. The stage bends, and the actors move accordingly. Again, activity belongs to space. Even light, which you might imagine as independent, follows the curves created by this structure. Space dictates the possibilities of movement. You begin to see a pattern. Whenever physics peels away layers of explanation, space moves closer to the center rather than fading away. It carries energy. It possesses geometry. It influences motion without touching anything. And this creates a subtle discomfort. If space can stretch, curve, and push, then calling it empty feels almost misleading. The word survives only because space does not look like the solid objects you are used to. But absence of solidity does not mean absence of reality. Think of a melody. You cannot hold it in your hand, yet it shapes emotion and action. Its reality lies in structure, not substance. Space may be similar, defined by relationships and rules rather than material texture. The consequence is profound. The universe is not built from objects sitting inside neutral emptiness. The emptiness itself determines what objects can exist, how they move, and how the cosmos evolves. Your Original intuition, empty space as passive, has nowhere left to stand. Space is not the quiet background. It is a participant in the unfolding story. And once you accept that, the question shifts again, becoming more unsettling than before. If space behaves like an active ingredient, then asking why it exists may be asking the wrong thing entirely. Because perhaps existence itself requires something like this, a framework capable of carrying structure. The question starts to turn inward, not why space exists, but whether existence could look like anything without it. You began with a simple question: why does empty space exist? It sounded like a question about origins, as if space were one object among many that might or might not have appeared. But now the question starts to fold back on itself, because every attempt to imagine existence without space quietly fails, not because physics lacks imagination, but because removing space removes the possibility of relations. And relations are what give meaning to existence in the first place. Think about what it means for something to exist. It must be different from something else. It must have some location, some persistence, some way of being distinguished. Even abstract ideas depend on contrast and structure. Without a framework allowing difference, existence becomes indistinguishable from non-existence. This is not a physical argument yet. It is a conceptual one. Suppose you insist that reality could exist without space. Where would anything be? How would two things differ? What would it mean for one event to precede another if there is no structure connecting them? The question collapses into silence. You begin to suspect that space is not a later addition to reality. It may be part of the definition of reality itself. Feynman's perspective quietly supports this inversion. Fields do not live inside space the way fish live in water. The fields and the structure of space are deeply intertwined, inseparable in the way equations describe the world. If you remove the framework, you remove the possibility of fields, and therefore the possibility of particles, and therefore the possibility of events. Reality needs a stage, not because the stage is convenient, but because existence seems to require relationships, and relationships require structure. The mind resists this because it wants a deeper layer, something beneath space that explains it. But each layer of explanation in physics has a habit of dissolving into more abstract relations rather than solid foundations. The search for a final object underneath everything keeps failing. Instead, you find patterns, symmetries, constraints. Space begins to look less like a thing and more like the set of rules that allow things to appear at all. And now the original question changes shape. Asking why space exists may be like asking why logic exists or why numbers relate to each other. It might not be something that happened. It might be something that must be, not guaranteed. Physics does not claim certainty here, but unavoidable given that anything exists to be discussed. This realization is quiet but destabilizing. You stop picturing a universe that could have been a blank void with or without space. Instead, you see existence as already structured from the start, as if nothing was never a genuine option. The idea of emptiness shifts one more time. Empty space is not a residue left after removing objects. It may be the minimal condition for possibility itself. And if that is true, then the question why does space exist is approaching a boundary where physics and philosophy begin to overlap, a boundary where answers become less about mechanisms and more about perspective. The final step is not to resolve the mystery. It is to see how the mystery itself changes once your intuition has been stripped away. At the beginning, you imagine emptiness as a void, a silence waiting for something to break. Now that image feels difficult to hold. Space refuses to behave like absence. The vacuum hums with activity. Fields spread everywhere. Geometry bends, expands, influences. And the attempt to imagine true nothingness dissolves into contradiction. So what remains? Not a final answer in the usual sense. Physics rarely gives that. Instead, it offers a quieter shift, the kind Feynman favored, where the world becomes simpler and stranger at the same time. The shift is this: reality may not be made of things at all. What you call objects could be temporary patterns in an underlying structure that never disappears. Particles are disturbances. Forces are relationships. Even emptiness is a state with rules. Space is not the place where reality happens. Space is part of what reality is. This does not mean physicists have discovered why space exists in an ultimate, philosophical sense. They have not, and Feynman himself resisted pretending otherwise. He warned against mistaking mathematical success for complete understanding. but his approach quietly dissolves the question you started with: if fields are fundamental, if activity cannot vanish entirely, if existence requires structure, then asking why space exists begins to resemble asking why there is structure rather than chaos, or why possibility exists at all. And here physics grows quiet, because beyond a certain point, explanation becomes description. Equations describe how space behaves, not why existence takes this particular form instead of none. There is uncertainty here, and it deserves honesty. Maybe future theories will reveal that space emerges from something deeper: information, geometry, quantum relations we barely understand. Maybe space itself is not fundamental, only a useful appearance, but even those possibilities do not return you to the comforting idea of nothingness. They only push the structure deeper. The unsettling lesson remains: you cannot easily separate existence from the framework that allows it. And so the philosophical shock arrives, almost gently. The opposite of something may not be nothing. It may be incoherence. Perhaps reality does not stand on a foundation of objects, but on a foundation of possibilities, a network of relations that cannot be reduced to emptiness. This is where the intuition fully reverses. You once thought empty space was what remained after reality was stripped away. Now it appears as the condition that allows stripping, comparison, and existence itself. The quiet stage you ignored may be the main character all along, and that realization leaves you with a final, uncomfortable sense of awe. Not because the mystery has been solved, but because the question changed shape while you were asking it. You wanted to know why empty space exists. You end up wondering whether existence could ever have looked like anything else. Space no longer feels empty. It feels inevitable.